Hello, and I want to welcome you to the second half of logarithmic functions. This is part 2. Okay, so something you'll need to know about the properties of logarithms. Number 1, that you have a log and you have the base. We're going to call it b. And then you have that it's going to be 1. You need to know that's going to be equal to 0. When you have a log and you have a base of b, and then the equals will be b. So you're going to need to remember that's going to be equal to 1. You need to remember the log b with the base of b. And then you have b with the power of x. That this whole thing is just going to be equal to that power x. Additionally, if you have a base of b with the power of the log, where its base is b, to a power of, or just x, then that whole thing is just going to be equal to that power x. There's going to be some important properties to remember when solving some types of logarithmic equations. So let's look. Remember, there's no base for the logarithm that is understood to be a base of 10. So for these examples, evaluate the expressions without using a calculator. We do not see a base, so we know that there's the automatic 10 that's already justified for that. So to rewrite this, we want to set it equal to x. Now, we know that we have our base of 10 to a power of x equals 1 over 1,000. So we need to rewrite the base. 10 is in its only form that can be in. So we're going to work with the 1 over 1,000 and hope that we can get it to be a power with a base of 10. Well, the trick is that 10 to the third power is 1,000. And if you put the negative 3 instead of the 3 for a power, it's actually going to flip the fraction to be 1 over 1,000. So 1 over 1,000 is actually equivalent to 10 to the minus 3 power. Now, since our bases are the same, you can set our exponents equal to each other and solve for the variable. In our case, we are lucky enough to have the variable already solved. X equals negative 3. For this next part, we have log, and there's an initial base of 10, 10 to the fourth power. And if you refer to our properties of logs, that this is just what it's going to be equal to. Because these bases equivalent, what you could think of as canceling out, leaving you with just the power of 14. And finally, to conclude this video, let's talk about natural logarithms. Logarithm functions with base e is called the natural logarithmic function. The function f of x equals log base e x is usually expressed as f of x equals ln x, read as L of n. And this e right here is actually called Euler's number. All properties of common logarithms are the same as natural logarithms. That's very important to note. For these examples, evaluate the expressions without using a calculator. So ln e to the 6th. You can think of this as already having a base of e. So you can kind of think of the ln base of e and then e to the 6th canceling out, just leaving you with the power of 6. So that's what it's equivalent to. This statement is equivalent just to 6. Okay. Again, ln has a base of e. These kind of cancel out, just leaving you with what's there, or just 1. Or excuse me, that's going to be 0. Giving you with just 0. Okay, and over here, the ln base of e and then the e will cancel out, just leaving you with just the 1. And here, remember that our ln has a base of e, canceling out, just leaving us with that power. So this statement just equals 54.